Hi guys. So we are going to continue our discussion of trig, just like we've been talking about the last couple of classes. So just to refresh you, since it has been a couple days, the last couple of classes we talked about the basics of the trigonometric ratios. So we talked about sine, cosine, and tangent, specifically how sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. I will include an attached link of these notes completed in case you need a refresher, because I know we do keep our binders at school, and unfortunately we don't have access to them right now. So I will attach this entire sheet completed so that you do have some things to reference. But just to refresh you, we always talk about sine, cosine, and tangent in regards to an angle. So here, when we're looking for the sine of A, we want to know the sine based on this specific angle. And then sine is opposite over hypotenuse, so we're going across. That's my opposite, and then across from the right angle is my hypotenuse. That gives me the sine of A, which is 5 over 13. And then you could continue on from there, filling in the cosine and the tangent accordingly. So we will be using sine, cosine, and tangent for this entire lesson. So I did want to make sure that we are comfortable with what those exactly mean. So if you remember from last class, we kept talking about SOHCAHTOA, this acronym that you could use to help remember what sine, cosine, and tangent stand for. So the SOH, the S stands for sine, and sine is equal to the opposite side over the hypotenuse. The C stands for cosine, and that's equal to the adjacent side over the hypotenuse. And then the T stands for tangent, and that's equal to the opposite side over the adjacent side. So having these ratios down is really going to be key, because that'll make it easier for you when it comes to what today's lesson is really focusing on. So the O is for O and opposite, the H is for the H and hypotenuse, the A for adjacent, the H for hypotenuse, the O for opposite, and the A for adjacent, just to really slam that into your brains before we keep going. Now, if you do want to write this down somewhere on a separate sheet of paper while you're following along, now would be a great time to pause and do so that you can use this for the next part of the lesson, because we are going to need it. So the next part of this lesson, so we've talked about the basic ratios, what the opposite over the hypotenuse would be, but it goes further than that. We can actually use trigonometry to help us find missing side lengths when we're given a triangle with an angle and one other side length, as long as it's a right triangle. So you'll see in number 4, before today, the only way that you knew to find x was Pythagorean theorem. And you actually can't do Pythagorean theorem here, because we don't know this side, and we also don't know this side. So Pythagorean theorem would not be very effective in this case, because we are missing 2 sides. But since we're given that angle, that 28 degrees, we actually still can find that missing side. We just need to use one of the trigonometric ratios that we discussed the past couple of days. So our main focus is really going to be on finding side lengths using trig. So you'll see the directions say solve for x and round to the nearest tenth. So we always want to round to the first decimal place, round to the nearest tenth. So in order to find our missing sides, we want to first start by labeling the triangle based on the angle that we're given. So if you look at number 4, which is the first example here, if we look at 28 degrees, that's the angle that we're given. We want to label all the sides based on this 28 degrees. So I know that across from the right angle is always my hypotenuse. So I'm going to label next to the 19 with a little h for hypotenuse. And then if I go across from the 28, put my finger on the 28 and go straight across, that's my opposite side. And then the adjacent is the side next to the angle. Now that I have all of this labeled, I want to keep in mind the SOHCAHTOA acronym. that we talked about before, because this will help make it clear which ratio we're going to use. So now from here, I want to look at what sides give me the most information. If I look at this A, this adjacent, I have no information here. I don't know a variable for this side length. I don't know a number for this side length. So this A is pretty much useless in this scenario. What I do have some information for is the opposite and the hypotenuse. So even though it's a variable, I still know something about that opposite side. I know I want to find that opposite side. So I need to use it. And then I have a value, a number for my hypotenuse, which is 19. Now, O and H correspond to O and H in sine. So that's my hint that I'm using sine here. So the way that we set this up, we're always talking about these ratios in regards to the angle in question. So I would write sine of 28 equals, now my opposite side is x, over my hypotenuse, which is 19. That's my initial setup. If this were a test-like scenario, you would get partial credit for something at this step. But I want to go further. It says solve for x. I didn't solve for x. So I want to multiply both sides by 19 because x is being divided by 19. So if I multiply, that will cancel both of those. And then I'm left with just x equals 19 times the sine of 28. Now here I'm almost done, but I want an actual number. I need a value for that side length. And right now I don't have a value for that side length. So my next step is I need a calculator. Now I know that you guys don't have the calculators that are at school, but you can either download on your phones an app called Calculate 84. I believe it's available for all phones, and that gives you something that looks just like the calculators that we use in school, or even easier on your Chromebooks or your phones, whatever you're watching this on. If you just go to Google and Google calculator, Google has a fairly nice one that we can use for our purposes. So you can use this, you can use that app. I just would not recommend your phone calculator because they are kind of finicky. And this is the first time that we really need some of those special tools that are on the more advanced calculators. So it's really not the best bet. So you do need a calculator to solve this. Now it says make sure your calculator is in degree mode. That's an important part of this because you will get the wrong answer if it's not in degree mode. So when we're looking at the Google calculator, if we look, it says RAD, and that's highlighted in a darker colored font. I want to change that and press DEG. I want that to be highlighted darker. That means that I'm in degree mode. As a side note, this is not relevant to the problem itself, but just to check that you're in degree mode, if you just type in COS, press the COS button, and then 60, you should get 0.5. If you are not in degree mode, then it is not in 0.5. So for this specific problem, I need to find 19 times the sine of 28. Now that's a complicated ratio. It's not something that you would know in your head. So what you would just do is type 19 times and then the sine of 28. And that gives me 8.91. I want to round to the nearest tenth. So that would just leave me with 8.9. And that's my final answer. I know this might seem a little weird. Let's push through, do a couple more problems. There's not much more to this lesson, just one other tiny thing that might change. And hopefully you'll build some confidence through the practice that I have attached to this Google Classroom activity. So starting the second one, you're always doing it in regards to the angle in question. So I'm given 41. That's what I'm looking at here. And I want to label my sides. That's my second step. So if I look, I don't have anything for the hypotenuse. I'm still going to label it with an H. If I go across from the angle, that's my opposite. And then the side next to it is my adjacent side. It's my first step, labeling opposite, adjacent, and hypotenuse. Very, very similar to what you already have been doing in the classes prior to this. Then the new thing, I want to circle the sides that I'm given. So I have an x, that's still something I'm given, and then I have 32, something that I'm given. So in this case, I'm using opposite and adjacent. If I look at TOA, that is what I would need here. So this is a case where I am using tan. Again, it's always the sine, cosine, or tangent of the angle in question. So that would be tan of 41, that's my angle, equals x, that's the opposite side, over 32, the adjacent. Now it's x divided by 32, so to move that 32 to the other side, I have to multiply both sides by 32. And on the right, these cancel, and then I'm left with x equals 32 times the tangent of 41. Then going back to my Google calculator, I can do 32 times the tangent of 41, and I get 27.8. That is my answer for this one. So 6 and 7 are very similar to these guys. What I want you to do, I want you to pause this video and try 6 and 7 on your own. I am going to give you just the answer, nothing else, just the answer, so that you can check yourself, similar to what we've done in class before. But I want you to pause, show all the work, try 6 and 7 on your own, and see what you come up with. So after you've paused, you should have gotten 24.3 for 6, and then 7 should be 11.4. If you did not get those answers, just be sure that you filled it in the right way, you labeled the sides accordingly, and you picked the right function. That's probably the biggest mistake, is accidentally picking the wrong function. So those are your two answers for 6 and 7. Now, 8 and 9 are a little bit different, same concepts, but one little tiny step changes. So just be careful with these guys. So looking at 8, same thing. I'm looking at this angle 33. That's my angle in question. And I want to label all the sides based on that angle. So I always like to start with the hypotenuse. It's across from the right angle. Here, this is my hypotenuse. If I go completely across from that angle, this is my opposite. And then my adjacent side is that one next to that angle. So now I like to always circle what is useful to me. So the opposite, I have a number that's very useful, and the hypotenuse, I have a variable. So that means that I want to find the hypotenuse, and I don't necessarily know that. So I'm using opposite and hypotenuse. That means that this is sine, right? That's the SO in SOHCAHTOA. So it's always the sine of the angle, so the sine of 33, and it equals the opposite, which is 15, over the hypotenuse, which is x. Now, this is the part where things are a little bit different. So if you looked above, in all the examples, including the two that you did on your own, x should have been in the numerator. So here it was in the numerator, here it was also in the numerator. If we look at this example, things are a little bit different because x is in the denominator. When x is in the denominator, there's a couple more steps to solve. I'll show you the full way, and then I'll show you the kind of like trick that gets you to the example faster. So x is in the denominator. I can't deal with x when it's in the denominator. So the first thing I need to do is multiply both sides by x. On the right, those x's will cancel. That's what I wanted. I didn't want it in the denominator anymore. On the left, and I'm just going to move this guy over here because it is going to take up a little bit more space, I have x times the sine of 33 equals 15. Now, x still isn't by itself. I need that x by itself, and it's not. So my next step would be to divide both sides by the sine of 33, because that is what is attached to my x. On the left, that cancels, and I'm left with just x. That's what I wanted. On the right, I don't have 15 times the sine of 33. I have 15 divided by the sine of 33. So let's pause here for a second. So in this example, I have 15 divided by the sine of 33. Oops. 15 divided by the sine of 33. That is a little bit different than these guys, where I had 19 times the sine of 28. So as a little trick for you, whenever you get the variable in the denominator, you are dividing the number by whatever the ratio is. Here, the variable was in the numerator, so we were multiplying the number by whatever the ratio was. Just as like a little trick to help keep you going. And then we have to plug this into our calculator. So I am just going to do 15 divided by the sine of 33, and I get 27.5. That's my answer here. If you notice, when I was at this step, let me see if I can kind of erase some of this to make it more clear. So when I was at this initial step of just setting it up, right here, I had 15 over x equals the sine of 33. If I look at my last step, right before I plugged it into the calculator, I had x equals 15 over sine of 33. All I did was switch the positions of both of these guys. So I took the x and I brought it here by itself, and I took the sine of 33 and I put it in the denominator where the x was. You can always do that whenever you have a variable in the denominator, only in the denominator, and only one item on the left side. So that's kind of the trick that we're going to use from here on out. So looking at number 9, same steps. Here's my angle in question. Across from the 90 degrees, that's my hypotenuse. If I draw a line with my finger across, I wind up at the opposite side. And this should be opposite. There we go. And then next to is my adjacent. So let's get some new colors in here. Let's do this purple actually. So getting some new colors in. I need to circle what I'm given or what's relevant. So the adjacent's definitely relevant. That's 36. It's a number. I can work with it. And then this hypotenuse, it's the variable. That's what I need to solve for. So that's still relevant. I need that. Now I have A and H. Thinking about my acronym above, A and H goes with cosine. So then that would mean that I am using cosine here. And then I know it's always cosine of the angle. Here the angle is 43 equals the adjacent, which is, I'm not writing, 36 over the hypotenuse, which is x. So we're going to use this trick. I'll keep it in green to keep it organized and make sense. This trick from here, we're going to use that again. X is in the denominator, so I am going to switch the positions of x and the cosine of 43. So now instead, I have x equals 36 over the cosine of 43. This is probably the biggest area where students will have a tiny little mistake, is they'll multiply 36 times cosine of 43. So just be careful with which way it's set up. That's my adjacent 36. It goes in the numerator. Can't change that. So going to the calculator so I can get one final answer, I have 36 divided by the cosine of 43. And I've got 49. So that is my answer here. It should be 49. And what was the decimal place? 0.2. So 49.2. All right. So the same kind of thing here. I want you guys to try 10, try 11 on your own. As a hint for you, 10 will wind up being 1 where you will have to do something similar to 8 and 9. 11 is not like 8 and 9. 11 is like the other few. So now's a great time to pause the video, try 10 and 11 on your own, and then when you come back, you can get just the answer, just like the problems before, and just like when we do it in class. So now that you've finished, the answer for 10 should be 8.1, and the answer for 11 should be 4.8. If you got anything other than that, check your ratios, maybe try to erase your labeling, try it again, make sure that your labeling is correct. 12 and 13 are little bonuses for you if you feel like you want to complete them. They're word problems. They are relevant, they're related to the real world, but they are not required. Just to give you a hint of how you would set up ones like 12 and 13, you always want to draw a picture first. So it says Jake leaned a 12-foot ladder against his house. So here's Jake's cute little house. And then he leaned a 12-foot ladder against that house. So here's my ladder. And that's 12 feet. Then it says the angle formed by the ladder and the ground, so here's my ground, is 68 degrees. So that angle is 68 degrees. They want to know how far did he place the ladder from the base of the house. So that would be this side here. My drawing is not the best. It is very hard to write on these surfaces with one of these little stylus things. But that's how you would solve 12, and then 13 would be similar. If you choose to do these, they are bonus. That is great. You can email me and I will definitely help you. And I'll give you the answer to those. But now that you've finished the kind of formal lesson, this is attached to the notes that I have in Google Classroom. And our very first online official assignment after going through the lesson is going to be to complete this assignment. It will be graded for accuracy. You do not have to do it once. You can do it multiple times. We can have kind of a back and forth of like, okay, now try this one again, and so on. But I do want you to complete 1 through 9. It's nothing crazy, a little bit of each question type from the basics of trig that we have talked about so far. Once you complete it, you can post it back to me on that assignment in Google Classroom, or you can email it to me. It's up to you, but this is up next in regards to what to complete. If you have any questions, please, please, please don't hesitate to reach out to me via email. I will answer your emails. I'm by my phone pretty much all the time, and I do have my computer on me now that we are switching to this virtual classroom. But as I mentioned in that initial Google Classroom post, I am going to be available Wednesdays from 9 to 11 to answer any questions that you might have on Google Meet. So it is a platform kind of like FaceTime, but it's done through Google emails to make it more school official. So I will be able to answer any questions on Wednesday via that virtual chat. But if you have any questions in the meantime, please, please, please do not hesitate to email me. Right? Have a great weekend, you guys.